Welcome in the new edition of my book tour. The next book I want to discuss is Tolman, The Principle of Statistical Mechanics. This book is an extremely valuable book. It is one of the only books I know that deals with statistical mechanics from the classical point of view, while all books nowadays do it from a quantum point of view. This book really takes a classical point of view, which is wrong, but it takes it seriously and derives as much as it can classically. So you see here statistical ensembles in classical mechanics. You see here the Maxwell-Boltzmann distribution law is completely derived. We see here oscillation collisions. We see here one of the only derivation of the Boltzmann H theorem that I know of. And then the focus goes to quantum mechanics. It goes to defining quantum mechanics, and then it will get into quantum mechanics and ensembles in quantum mechanics. The Maxwell-Boltzmann, Einstein-Bose, and affirmative Rugg distribution in quantum mechanics. Change of quantum systems in time. And then the H theorem in quantum mechanics. And then finally, thermodynamics in quantum mechanics. This is an extremely beautiful, valuable book from which there is an enormous amount of things you can learn. This is definitely a book you want to go through at some point, but the drawbacks is there's no exercises. There's no exercises, and the writing is a bit ancient in the sense that it's a pretty old book already. Tolman is a really big, great figure. You see, it's his friend Oppenheimer. So it's a really old book, and you do notice it from the writing style, so that's a bit unfortunate. Then here we have also a very good book, Classical Electrodynamics, which is basically, it's not a textbook on electrodynamics, but it is basically a set of neat applications of quantum mechanics. So what it covers is multipole expansions. It covers image charges, a lot of image charges, complex variables in electrodynamics, which I'm really looking forward to, conformal mapping, separation of variables, relativistic transformation of electric fields, relativistic covariance, energy and momentum, the Feynman paradox, field and radiation, resonant cavity, test of the Coulomb law and limits of the mass of the photon. So these are magnetic monopoles, of course. So these are all pretty nice applications, but this is not a textbook that will teach you all of this on its own. It's really a complement to another book, at least that's what it should be. Next, another book by Nahin, Hot Molecules and Cold Electrons. This book is about the mathematics of heat, but also the construction of the telegraph. So we see here it has Fourier series, it has the heat equation, it has a solution to the heat equation, and then it has the telegraph equation and how we solve it. The book is, as you see, it is for laymen, but yeah, they must be pretty mathematically mature to be able to handle this book. A very good book, one of the best derivations of the heat equation I've seen so far in any book. Here's a nice one, The Forest of Physics by Norson, Travis Norson. This book deals with all kinds of physics and how they interact. So we see here the Copernican model, the law of motion, the Newton's law of motion. Then it goes into electricity and magnetism, and then it goes into atomic theory. So it deals with all kinds of, it kind of gives a brief overview of classical physics and how it behaves, and what you should know about it before going into quantum. It has a lot of experimental evidence and how to read experimental evidence, so it's a nice book. I haven't read through it yet though. Here's a book on the history of quantum mechanics, the historical and physical foundation of quantum mechanics. So the things it covers is the crisis of classical physics, the Bohr and Sommerfeld models, de Broyles model, invention of quantum mechanics, the wave equation, quantum statistics, Dirac notation. Then we have von Neumann, Einstein and Schrödinger. Then we come to operator algebras, spin 1/2. Then we have quantum computing, path integrals. So this is a pretty neat book on the history of quantum mechanics and what exactly led to the invention of quantum mechanics as a whole. So a topic that I'm very interested in, really. Here's a book on by Robin Ehrenhardt on vector. So this book is on the history of vectors and of vector calculus. So it covers Newton, it covers Maxwell, it covers Hamilton, it covers quaternions, it covers vector analysis, the quaternion war, it covers space-time, and it covers tensors, general theory of relativity. So it really covers everything historically. So here you see the cubic formula and the solution of that. It covers here the Pythagorean law of ancient Egypt. We see here the quaternions. So it's really the entire history. What I don't like on this book is that the author maybe goes a bit too woke at some points. I don't really mind that per se, but it really disturbs the flow of the story. Like, she'll be in some kind of talk about quaternions, and then she talks about women mathematicians all of a sudden without there really being a good reason for it. So that's a bit disturbing. Here we have Nastase, the Romanian author again, with his course on general relativity, graduate course on general relativity. It covers the usual general relativity things. So from stars, black holes, it covers entropy of black holes, fluid dynamics, then a bit of the quantum field theory and how it would relate. So yeah, nice book on general relativity. Definitely should not be your first book though. Here we have the annotated Turing, which is Turing had a nice paper on computability, and this book basically goes over this paper on computability, and it gives a lot of comments. So it goes over computable numbers, it goes over machines, quantum machines, it goes over the problem that Turing was really trying to solve, and it goes over the paper, and it leaves all kinds of very neat remarks. So here the gray box are the paper, and then you have the remarks by the author to really make you understand the paper. Yeah, this is nice. Here we have a book on the Noether's theorems of the conservation laws. So yeah, this is a book on the Noether theorems. So we have how the Noether's theorems came to be, the Noether's theorem themselves, the different theorems. It covers how people, or the reception of the Noether's theorems, and how people see it today. I have yet to read this book. I'm very excited for it. Maybe I'll read it on my vacation soon. Here's a book on chaotic dynamics. It's a basic book on chaos theory, but based on classical mechanics. So you see it's about chaotic motion, fractal objects, regular motion. It covers chaos in dissipative systems. It covers transient chaos. It covers all kinds of chaos. And you see its application in solar system, in engineering, in pollution. So yeah, nice book on chaos. Beautiful pictures. Yeah, it's a really good book if you're into physics and want to get into chaos as well. So yeah, it's very in-depth too. We just did Annotated Turing. This is a related book, the Annotated Gödel, which goes over Gödel's completeness theorem and the original paper. and it covers like the main ideas, the rigorous presentation, and it really covers everything, filled with helpful remarks. So here it's the same style. Every sentence of Gödel is being met with some heavy commentary. If you're interested in Gödel's paper, this is definitely something I'd recommend to go over. Here is one of Euclid's books. This is the first of Euclid's books. Where are the other two? I have them as well, but this is the one I'm reading to. Euclid's books only start really late in, but it has extensive commentary and everything. Then here we have a book on Heaviside, Oliver Heaviside by Nahin again. I think I have all his books. So we have the early years, the invention of the telegraphy work. We see Maxwell, how he interpreted Maxwell's electrodynamics. We see the Great Quaternion War, in which he was heavily involved against quaternions. The Age of the Earth controversy, and then the final year. So this is really about not only the life of Heaviside, but also about the science and the math he did in a very nice perspective. Then here we have another history of quantum mechanics book. So this is history of quantum mechanics. It goes over black body radiation. It goes over the origins of all quantum theory. Then it does atoms and early atomic models, Thomson and Nakaoka's atomic models. We have the photoelectric effects, we have the Rutherford hypothesis, Bohr's hydrogen atom, the Compton effects. We have the theory of electron waves, the Pauli exclusion principle, matrix mechanics, wave mechanics, uncertainty relations. We have quantum statistics, the Klein-Gordon equation, completeness and incompleteness, and we have the cat and the fox. So yeah, a very in-depth course on what prompted quantum mechanics to exist in the first place, and what did the founders of quantum mechanics really think about the science. Finally, for this video, we have here a history of Greek mathematics from Thales to Euclid by Heath again. So this is all about the Greek mathematicians. So what it covers is the number system of the Greeks. It's a very in-depth book, of course. Heath is always in-depth. Pythagoras, we have Thales, we have Pythagorean geometry, we have Plato's time. We have special problems, duplication of the cube, intersection of the angle, Zeno, we have Plato, we have from Plato to Euclid, and then we have a bit on Euclid itself. This is the authoritative history book on Greek mathematics.